welcome to lesson 5. We have a lot to cover today. I'm going to try to get through it as efficiently as possible, but yeah, there's a lot to cover. So last week we started working with multiplying multi-digit numbers. This week we're going to start getting into dividing multi-digit numbers. So first of all, we're going to start on page 78, and we're just going to look at number 2 where it says look ahead. So the key part here that I want you to, the key takeaway is multiplication and division are called inverse operations because they undo each other. So we think about them kind of like opposites, right? Or those fact families that we've worked with. Multiplication and division, they kind of do the opposite thing. So for example, the related multiplication and division equations 5 times 7 equals 35 and 35 divided by 5 equals 7 show that if you multiply a number by 5 and then divide that result by 5, you end up with the number that you started with. So that's the main takeaway from that page. I want to go down to A where it says start by listing products of the divisor 12 and multiples of 10. So you'll see that there's a table that says multiple of 10 and then times 12 of the multiple of 10. So for 10, you have multiples of 10, 10, 20, 30, 40, 50, right? We're counting by tens, the multiples of 10. And then 12 times the multiple of 10. So 12 times 10 is 120, 12 times 20 is 240, 12 times 30 is 360, 12 times 40 is 480. So each time we're thinking about it as a multiple of 10 and multiplying it by 12. So you can use related multiplication equations to help you divide bigger numbers. And then down below where it says C, you can also use an area model for division as well. So you'll see that we're starting with a box that says 12 times something, and the whole area is going to be 264. So thinking about it as area equals length times width, right? So we may know the area. In this case, they're saying we have 264 is equal to one side is going to be 12. And the other side is going to be an unknown number to get us 264. And that's where that table of multiples by 12, by multiples of 10 comes in handy. Because we see that we're going to fall in between some certain numbers. So 10 times 12 is 120. That's too low. 12 times 20 is 240. That's getting closer. 12 times 30 is 360. That's too high. So we know that our answer is going to be somewhere in between 20 and 30. So that kind of helps narrow down some of the options. So when we can figure out some of the things by multiplication, we can narrow down. Now I want to go back to what it's talking about with a divisor. So we're actually going to go ahead and turn to the next page, page 79. And you'll see that there is a chart. We're just going to focus on number 1, and it has some words. So the first word is dividend. The second word is divisor. And the last word is quotient. So we're going to start first by defining these terms and giving some examples. So in the box next to this column, it says in my own words, and then in the last boxes, it says example. So first we're going to define each term, and then we're going to give an example of each. So dividend is the number that is divided by another number. So that's what we're going to write. The number divided by I'm going to underline that part, divided by another number. So your example would be, I'm going to go ahead and write my example in parentheses, but you guys can go ahead and fill it in that last box. So an example would be if I have 24 and I divide it by 12, 24, the number that I am dividing by 12 is going to be my dividend. Okay? Okay, so that might kind of give you a clue about what divisor is. So a divisor is the number that you are dividing another number by. The number. And we're going to make this a little, yeah, so the number another number is divided by. Okay, and so here we have divided by again. Here we have the number divided by another number. So dividend is the first number. The divisor is the number another number is divided by. Okay, so the example, again, I'm going to use the same example of 24 divided by 12. 12 is going to be the divisor, the number that we are dividing 24 by. So now you probably have a good idea about what the quotient is. Quotient is an answer to a division problem. So let's go ahead and stick with our example of 24 divided by 12. 24 being our dividend, 12 being our divisor, the number we're dividing by, and our answer would be 2, right? So 2 would be the quotient in this problem. Okay? Okay, so now that we have some of the terms solidified, go ahead and turn to page 82. Remember that you can pause the video, so if you need more time to write, you can pause the video and come back to it. I'm going to go ahead and erase it since you guys can pause me. And in the meantime, go ahead and turn to page 82. So on page 82, the problem at the top says a toy company packs 504 robots into 21 boxes. So remember that with division, we're taking a whole group and we're dividing it up into its multiples, right? The numbers that we would multiply to create that, that number. So, I'm sorry, not multiples, it's into its factors, because factor times factor equals product. So we're taking the product and we're dividing it up into the two factors. So a toy company packs 504 robots into 21 boxes. So our whole group of robots that we're starting with is 504. We're taking that 504 and we're dividing it into a certain number in each box for 21 boxes, right? That's confusing. I'm going to go ahead and say it a different way. We have 504 robots. We have 21 boxes. So how many robots would be in each box if we have our 504 robots? That's better. All right, so on page 82, there's two model-its. One says you can use compatible numbers to estimate a quotient. So notice that it says estimate. So getting an idea, just like we did that with that first one of thinking about what that number could fall between using multiples. Or you can also use the inverse relationship between multiplication and division to estimate a quotient. So in the first one, they're showing you an area model where we have 500 is what we're estimating, and they're using 20 as one of the sides. So 500 is close to 504, 20 is close to 21. So we're just ignoring those ones for right now because they're messing everything up, and we're just going to focus on the 100. So we're going to think what number times 20 would get us 500. I'm going to ignore my zeros for a second and say, so basically that's like saying what number times 2 is going to get 50? Well, 25 times 2 equals 50. So if I add my zeros back in, 25 times 20, one more zero, equals 500. Okay, so we would know that our mystery number would be 25. So 25 is going to get us pretty close. So 21 times somewhere around 25 will get us 504. Okay, we don't know exactly if it's 25 yet, but we are a lot closer. We're not just shooting blind here, right? Okay, the second model, it says use their inverse relationship between multiplication and division. So again, we're thinking 504, we're dividing it into 21 boxes to get what our quotient would be. But we've already done that. We said 504 is the same as 21 boxes times how many in each box. So, and they have a table showing multiples of 10. So you have 10 per box. If you have 21 and then you plug in 10, you would get 210. That's not close enough. Okay, so let's try again. 21 times 20 is going to get us 420. Still not quite there, but closer. Now let's go to 30. 21 times 30 is going to get us 630. Oops, that's too high. So we know that our number is between 21 and 30, which we've already determined with our first model that 25 times 20 would get us about 25 times 20 would get us 500, which is close to what we would be getting for our answer. So we know that it's between 20 and 30. Is 25 between 20 and 30? Yes. So we know that our number is going to be around 25 to get us our answer of 504. Okay. So we're going to go ahead and not solve this problem. Actually, I'm sorry. Yes, we are. So I'm sorry. I'm going to change again. No, we're not, because there's a lot to get through, like I said. And so, so basically this is just thinking about steps for you to go ahead and solve your division problem. So the important takeaways, remember we're doing this short and sweet condensed version of this math lesson. The takeaways are you can estimate to find a reasonable answer. And you can also look at the inverse, again, opposite of division is going to be multiplication. So think what number you would multiply to get to your dividend, okay? So we're gonna go ahead and skip all the way to page 88. So we've got 3 sets of practice pages this week, just to give you guys a heads up on that. So likely what that will mean, not likely, definitely what that will mean is that we will do some of the problems when we meet in our small group on Thursday, and then you'll have more problems that you will also need to work on and finish up. If you need another week to go ahead and finish those up, then you can go ahead and turn them in a week later. That's okay. But I do want, there are going to be some problems that we do together and some problems that you will then be doing on your own. So right now we're going to skip ahead to page 88. A factory produces 768 buses and puts them in 24 buildings. So again, we have our full group, 768 buses, divided equally into 24 buildings. How many buildings would there be, right? So that's what the question is asking. How many buses are in, oh, I'm sorry, we have 24 buildings, we have 768 buses. How many buses would be in each building? So again, model, it says you can use the relationship between multiplication and division to estimate the quotient. But we're going to actually skip down to the second model where they're showing you an area model for division. So we worked last week with area models to show multiplication. For an area model for division, we're going to start off. We know that our total area, right, in this case is going to be 768. We have one side that's going to be 24. And we have another side that's unknown. So that's like saying area is equal to length times width. We're using the inverse of our division problem to solve for it. So we're saying 768 is equal to 24 times some unknown number. So we don't know one of the numbers yet, but we can use that inverse property of multiplication, of division, to go ahead and solve. So right now, I have 768, I have 24 on one side, and I have an unknown number on the other. Okay? So first, I'm going to think about what would get me close. So I'm going to use multiples of 10. I'm going to say 240. Oops. Just kidding. 24 times 10 is going to be 240. That's too low, right? Let's try 24 times, because I know one side is 24. Now let's multiply it by 20. Well, that's going to be 480. That's still too low, but I'm getting closer. Okay, let's try 24 times 30. That's going to get me 720. Ooh, I'm quite close. Still not quite there, but I'm really, really close. And then the last one, I'm going to do 24 times 40, which is going to get me 960. That's too high. So I know that I'm going to be right here around 30 for my other side. So let's go ahead. So when we do our area model, I'm going to try and get close to my total of 768. So I'm going to leave 768 up here right now, 768. I know that 30 multiplying 24 by 30 is going to get me close. It got me 720, so I'm going to take away 720 from the 768 that I had, and that's going to leave me with 48. Now I'm going to see how many times 24 will go into 48. So I'm going to add on another section and think about what times 24 is going to get me 48. Well, 2 times 24, I have 48. 2 times 24 is 48. When I take it away, I have 0 left over. So that means that my buses, my total number of buses split equally into 24 buildings, I would have 30 plus 2 in each building. So basically what we're doing is like the opposite of the distributive property of multiplication, right? So we took one part of our dividend, we took away what we know. We know that 30 got us close. And then we found out what the remaining part would be to get us the rest of the way there. And we added it to our first part. Okay? So now what I would like you to do is I'd like you to go ahead and turn to page 90. So, and we're going to skip number 1 because it's the same problem that we just worked on. Or I'm sorry, not problem number 1, problem number 7. We're going to skip number 7 on page 90. And we're going to skip right on down to number 8. So we have a new problem for number 8, and it's going to take us 2 parts. So Dante has 468 cards in his sports card collection. He buys cards in packages of 12. Complete the table and give an estimate for how many packages of cards Dante has bought. So it's saying that they come in packages of 12. How many times did he buy packages of 12 to get his 428 cards, right? So here we're setting it up as a multiplication problem, but we're also thinking of 468 divided by 12 is going to get us the number of cards, the number of times he bought packs of 12 to get his 468 cards. So first we're going to go ahead and complete the table. So first we're showing multiples of 10 because it has number of packages, 10, 20, 30, 40, 50. So we're going to go ahead and say for packages of 10, we're going to multiply it by 12, right? And so we would get 120 for the number of sports cards. So number of packages, 10, 12 in each one. 12 times 10 is going to give us 120 cards, but he has 468. So I've written it out this way just because I'm not writing out a whole table. So for you to understand that this is just a portion of the table, I'm not writing it as a fraction. 10 is the number we're multiplying 12 by. 120 would be the answer. So in the next part, you have 20. We're going to multiply 12 by 20. That gives us 240. Still not enough. So let's keep going. If we multiply 12 by 30, we get 360. Still not quite there, but we're getting closer. If we multiply it by 40, we multiply 12 by 40, we get 480. And that's above. Now they have also multiplying 12 by 50, which would get you, that doesn't seem right. Hang on just a second. 12 times 50. So we have 2 times 0, 0. 5 times 2 is 10. 5 times, yeah, 600. The book is wrong. We should have 600 for our packages of 50. So I'm feeling a little nervous about that because the book is telling me something else and I have to go by what the book says, but my common sense says that I'm right on that. So, so now that we've completed the table, it says, give an estimate for how many packages of cards Dante has bought, right? So we said that 360 was too low, 480 is too high. So it's somewhere between 30 and 40 packages. And we could say it's probably closer to 40, right? Because 468 is pretty close to 480. So now that we have an estimate, now number 9 says refer to the situation in problem 8. Complete the area model to find the quotient 468 divided by 12. So we're going to start with our rectangle. Remember, we're thinking of area as length times width. So our total area would be our dividend, 468. Our divisor is 12. And so we're trying to figure out the quotient, right? So we know that when we multiplied by 30, we got 360. When we multiply by 40, it's too high. So we can't put 40 in here because that's going to be too high. That's going to get us over our number. So we're going to start off with 30. And we're going to take our 468 and we're going to subtract the 360 that we would get when we multiply 30 times 12. 8 take away 0 is 8. 6 take away 6 is 0. 4 take away 3 is 1. So we're left with 108 cards that still are not yet accounted for. So now I'm going to think about what I would add on to that, multiply by 12 to get close to 108. So I'm going to go ahead and think through. I'm going to think through my I'm going to think through my 12 facts, okay? So I know that 12 times 10 is going to get me 120. I need 108, so I'm going to go lower than 10. So let's think about 12 times 9. 9 times 2 is 18. 9 times 1 is 9, plus 1 more makes it 10. So that is my 108. So my other piece of my quotient here is going to be 9. So I would have 108, take away 108, leaves me with no cards left over. So we know that Dante bought 30 plus 9 packs of 12. 30 plus 9 is 39. So Dante bought 39 packs of 12 to get him his 468 sports cards. Okay, go ahead and skip on over to page 94. Because now that we have talked about an area model, we're going to start talking about partial quotients and start working with the standard algorithm for long division. Remember, an algorithm are just the steps that you go through. So with your area model, you're basically already thinking of partial quotients, right? So you had 30 times 12 makes 360. You take that away from your total dividend to get 108, and then you think about what number times 12 would get you 108. We worked backwards to find that we got 9, and then we added our two quotients together to get the answer. So now what we're going to do is we're going to start working. This is not quite the full standard algorithm, but it's getting closer to what you're going to be doing for long division. So you'll see on page 94, they're giving us a problem. The grocery store only sells eggs by the dozen. There are 12 eggs in 1 dozen. If there are 1,248 eggs in stock, how many dozens of eggs are there? Okay, so they have it written out as an area model, right? We have 1,248 eggs. They're divided into packages of 12. So how many packages would there be? We're going to think of it as 1,248 eggs is the same as 12 times how many packages, or area equals length times width. So we have our area model, and we're going to think of it as 1,248 is the same as 12 times what number? So I happen to know, I'm looking at 1,248 and 12, and I'm thinking, wow, 1, 2 in the first part of my number here, and 1, 2 here. So I'm going to go, oh, and my lesson's being interrupted by an announcement. So we're going to just go ahead and keep going like nothing is happening. So I have 12 times what number is going to get me close to 1,248. So I see 12 at the beginning here. I'm going to ignore these other two and pretend that those are zeros. So I'm going to think 12 times what number is going to get me 1,200. So 12 times 100, that would get me my 2 zeros to make it 1,200, right? 12 times 1 is 12. Add my 2 zeros to make it 1,200. So I know that at least part of my quotient is going to include 100, because that gets me pretty close, and then I only have 48 left to deal with. So I'm going to say the first part up here is going to be 100. 1,248, take away 1,200 is going to leave me with 48. So now I need to think about what times 12 is going to get me 48. I know that that's going to be 4. 48, take away 48, leaves me with 0. So my answer would be 104. Okay, so that's the steps with the area model. But now we're going to start working with our long division model using partial quotients. So to do long division, we write it out 12,048. That's our dividend. Our dividend is going to be in this little L-shaped box, and our divisor is going to be on the other side. So we have 12 over here. So I'm going to think about 12. I'm going to look first to my first category. Can 12 go into 1? No. So I'm going to look now at my next place value. Can 12 go into 12? Yes. It goes in 1 time, but then it's not 12. It's not 12 ones, it's 1200s, right? So I'm going to put in my 2 zeros for 1200. So 100 times 12 is going to give me 1200 or 1200. If I take it away, I get 48. Now I'm going to think about what number times 12 is going to get me 48. I know that that would be 4. I'm going to write my other quotient right above my first part of my quotient. 4 times 12 is 48. When I take it away, I have 0 left over, so I don't have any remaining eggs. I'm going to add these two parts of my quotient, and I can tell that once again, my answer is going to be 104. So this is just part of starting to work with the standard algorithm. So we will work more with, actually, we're going to do one more problem. Go ahead and turn to page 96. Again, we're going to skip problem 8, and we're going to skip right on down to problem 9 to have a little bit more practice with using partial quotients, which is going to get us one step closer to our standard algorithm, which we will cover next week. So number 9, Carlos has 1,134 pennies. He puts an equal number of pennies into 27 different glass jars. So he's breaking up his pennies into 27 groups. How many pennies are in each jar? So we started with 1,134. That's our dividend. Our divisor is 27. So now 27, can I put it into 1? Nope. Can I put it into 11? Nope. So I'm going to look at 113 and think about what would get me close when I multiply 27 by what would get me 113. So again, I'm going to think about my multiples. I'm going to think I have 27, oops, 27 times 10 is going to get me 270. So that's too high. So I need to go lower than 10. Okay, 10 is always a great place to start though with hundreds because it's going to get you some kind of idea. And they're really easy to multiply by. So 270 is too high because I'm just looking at this first part of 113. So let's go ahead and try 27 times 9. So I would have 9 times 7 would be, let's see, 63. So a 3 there, 6 there. 9 times 2 is going to be 18 plus 6 more, 18, 19, 20, 21, 22, 23, 24. Still too high. Okay. Now, I'm also noticing that these numbers went down, like we're going to need to skip down quite a few. So I'm going to go ahead and just skip on down to 5. 27 times 5 and see what that would get me. So 5 times 7 is going to get me 35. 5 times 2 is 10 plus 3 more would make it 135. Okay, I'm a lot closer, right? So I have 135, but I need to get 113. I'm not that far off. So let's go ahead and now try 27 times 4. 4 times 7 is going to get me 28. 4 times 2 is 8, 9, 10, 108. So we now know that 27 multiplied by 5 is 135 and multiplied by 4 is 108, and that's going to get me really close. So I'm going to go ahead and choose 4 because 5 is too high, and I'm going to put my 4 here. But remember, that's like if we were just doing 113, or yeah, 113, but I'm actually talking about 1,134. So I'm going to pretend that this is a 0 and say I'm multiplying now by 40. So that would be like saying multiplying by 50 and adding a 0 at the end. So instead of 135, I have 1,350, too high, and 1,080, that's too low. So again, 40 is going to get me somewhere in the middle, and I'm going to refine it from there. So I know that 40 times 27 is going to be 1,080. I'm going to subtract to find what the difference is. I have 4 here. I can't take 8 away from 3, so I'm going to regroup. 13 take away 8 is going to be 5. 0 take away and 0 take away. So I have 54 that I'm left with. So now I need to think about what number times 27 is going to get me 54. Well, I know that 25 times 2 is 50. That's pretty close. So let's try 2 times 27. 2 times 7 is 4. 2 times 2 is 4, with 1 more makes it 5. I get 54 exactly. Another announcement. So now I have 40 plus 2 as my partial quotient. When I add those together, 40 plus 2, I get 42 as my final quotient. All right, so we are going to go ahead and stop there for today because now the loudspeaker is coming on, because of course it is. We'll be going over the 3 practice pages in our meeting on Thursday. And I'll see you then. Okay, bye.